All right, guys. Maybe you can see me. I don't know. I'm super excited, and as you can hear, I got the Disney music playing in the background. Um, Anywho, this week we're gonna have two lessons for you. One is gonna be calculus in motion, and we're actually gonna stick with that theme for both our lessons this week. Okay. So give me a second. Let me pause this music so we can get started with a little bit of math. Okay. Give me a second. All right. So I turned the music off. Our EQ today is how is calculus related to motion? Okay. So sorry for the sounds on the slides. Oh, I don't know how to go. Hold on. All right, so apparently I'm going to be stopping and going on the video. No big deal. Calculus in motion, okay, we're going to be looking at position, velocity, and acceleration. Position can be one of these three, S of t, x of t, y of t, any type of that kind of letters, okay? And velocity is going to be v of t. Acceleration is going to be a of t. So if this is motion, what do you guys think the T represents? Time. Great job. All right. Okay, so looking at each of these pieces, position is going to be where on some number line that our object is. Okay, so if we're looking at like a football field, what yard line is the object on? What floor is it on? Meaning like, if you have like 8 floors to a building, that kind of a thing. And our units of measure are feet, meters, inches, kilometers, anything like that, right? Just single unit lines of units of measurement. Okay. All right. Velocity. Okay. Velocity depends on how fast the object is going, so that's its speed. But what makes velocity special is that the direction matters. Okay. So when an object is moving up or to the, is this your right? I don't know. Sorry. Up or to the right. Then they will have a positive velocity versus objects that are moving down or to the left, they will have a negative sign for their velocity. Okay. You guys may know that from physics or something else. So hopefully it's not brand new to everybody, but with velocity, the sign matters. Okay. So it'll be how fast it's going. But if it's going up or to the right, it's going to be a positive number. And if it's going down or to the left, it'll be a negative number. Okay, when an object is stopped or if it's said to be at rest, the velocity is 0, okay? And then some units for velocity would include feet per minute, kilometers per hour, meters per second, miles per hour. Basically any sort of unit of measurement per unit of time. Okay, so miles per hour is a speed, but velocity is going to take into account what direction our object is going. Okay, I've been talking a little bit about speed, right? So speed is how fast your object is going, and it doesn't matter what direction. And so here you can see that speed would be the absolute value of velocity. So it would be positive no matter what. All right, guys. Sorry about that. Here, okay, if the car is stopped, its speed is 0 miles per hour. Its velocity is 0 miles per hour too. Okay, so stopped, 0, 0, signs don't matter, and so on. Okay, so here's an example where if Montclair is in the middle and we got LA to the west of us and San Bernardino to the right of us, or excuse me, to the east of us. Okay, so based on the car that you see here, okay, a car is going to the right from Montclair to San Bernardino. Its speed is 60 miles per hour, and so its velocity would also be 60 miles per hour. Okay, it's positive because it is going to the right from Montclair towards San Bernardino. Okay, versus if the car was going to the left from Montclair to LA, to LA, the speed instead, or excuse me, the speed would still be 60 miles per hour, but we would say its velocity is negative 60 miles per hour because it's traveling to the left. Okay, so negative 60 miles per hour is the velocity because the car is traveling to the left. Okay, so now that we've talked about our position, right? So where the object is, and our velocity, which is the speed, but also taking into account the direction, right? Now let's look at the third piece that we want to look at is acceleration. So how fast is the velocity changing? Okay, so a positive A means the wind is blowing you to the right or up. Okay, so blowing to the right or up. And then a negative A means that wind is blowing you to the left or down. Okay, so it's this force behind the object. And so if the wind is blowing to the right or up, then positive A, positive acceleration, and blowing to the left or down, negative acceleration. Okay, here's a fun fact for you. Acceleration by itself cannot tell you if an object is speeding up or slowing down. Okay, because I could have a positive acceleration and still be slowing down. So, right, the wind could be blowing me in one direction, but if I'm going in the opposite direction and wind is blowing against me, right, I could be slowing down even if the wind is positive, if it's blowing to the right. Okay, so let's look at our little example here. So if you are going to the right, all right, based on that car there, going to the right, and the wind is blowing you to the right, what's going to happen, right? So if you're going in that direction and then the wind is pushing you into that same direction, are you going to be speeding up or slowing down? Good. You're going to be speeding up. I know that's what you guys thought, right? And so here my velocity was positive, right? Velocity being greater than 0 is positive. And my acceleration was also positive, okay? Here, let's look in the other direction. So if the car is driving to the left and then the wind is also blowing to the left, right? So if you look, the wind is blowing behind the car, right? So what's going to happen? Good. He's going to speed up too, right? In this case, since you're going to the left, your velocity is negative. And if you were, the wind was blowing you to the left, acceleration is negative. Okay, and so let's look at another situation here. If you're going to the left, so the car is going to the left, and then the wind is blowing to the right. So the wind is blowing in the opposite direction that you're going. Have you guys ever been that? Like, oh my gosh, one time in college, I went to Cal State San Bernardino, known for their super windiness, and I remember walking to school, like trying to walk from my car into the building, and the wind was just blowing against me, and I could just feel like my body was literally like, so normally you walk like this, my body was literally like this, like walking towards school, and the wind was just pushing me. Was I being sped up or was I being slowed down? Slowed down, right? So here, cars driving this way, wind is blowing the opposite direction, it slows you down. So you'll notice here with the going to the left, velocity is negative. And when the wind is blowing to the right, acceleration would be positive. Okay, so wind blowing to the right, acceleration is positive. And this caused us to slow down. Okay, last situation, if the car is going to the right and the wind is blowing left, again, this is going to cause you to slow down. Okay, so here velocity is positive because it's being driven to the right, and then the wind blowing to the left, that causes acceleration to be negative. All right, so to recap here, the object is speeding up if velocity and acceleration have the same sign. Okay, so our first example, both were positive, we were speeding up. Second example, both were negative. We were speeding up still, right? When I was going towards the left and the wind was blowing me towards the left, that caused me to speed up. All right, so when the velocity and acceleration have the same sign, the object is speeding up. when speed and velocity, oops, sorry, we're not at that slide yet. It says, for example, here, speed is increasing if velocity and acceleration have the same sign. Super similar writing, right? So next slide. Okay, our object is slowing down if the velocity and acceleration have opposite signs. So when we were driving to the right and wind was blowing us to the left, that caused one was positive, the other was negative. And so then we were slowing down, and then vice versa. When the one was negative and the other one was positive, we were slowing down, okay? Because we're going in the opposite direction of the wind, and it's causing us that force, and we're not speeding up, okay? All right, so here we go. Here's where the calculus comes in, okay, guys? So we have position, velocity, and acceleration, okay? Position, turns out when you take the derivative of the position function, you get velocity, okay? So velocity is the derivative of your position function. And then acceleration, same thing, acceleration is the derivative of your velocity function, okay? Going the other direction, okay, super same thing, just the opposite direction, right? So if you started with acceleration and you took the antiderivative of the acceleration function, you would get the velocity function. And then similarly, if you started with the velocity function and you took the antiderivative of it, you get the position function, okay? So I like to put them in order, S then V then T, and the derivative of S is V, the derivative of V is A, okay? And if I was going the other direction, the antiderivative of A is V, and the antiderivative of V is S. All right, so here's a super quick little example, okay? The calculus of motion. So if I started with, if I start with my position function, okay, and I want to know the velocity function, I take the derivative, okay? So if the S of t is t cubed plus 3t plus 2, I take the derivative and I get 3t squared plus 3. And then if I wanted the acceleration, I take the derivative again, okay? So my acceleration is just 6t. Now, I can do it the opposite direction, right? Oh, don't worry about that. Okay, so opposite direction. If I start with A of t being 6t, okay, the antiderivative of that would be add 1, divide by the new power, right? So add 1 gives me the 2 there, and then dividing by 2, 6 divided by 2 is 3. So 3t squared plus c. Don't forget the constant, okay? Then if I do it again to get the position function, I would add 1, divide by the new power. So adding 1 to 2 is 3. Dividing that by 3, my 3's cancel. And here, okay, this was a constant, right? And so my constant would now get a t, right? Just like when we had 5, the antiderivative of 5 with respect to x would be 5x, okay? Same thing, I got a constant, and the antiderivative of that constant gets the variable, so it's ct, okay? Plus the second constant. I got to label it with this little 2 right here because it's not the same number as this c, okay? So that's going backwards from acceleration to position. All right, so let's try a couple problems, and then you have a couple problems for homework, okay? And I'll provide the answers on the slide that I provide. Okay, so an object is moving along a line such that its position function is 2t cubed minus 21t squared plus 60t plus 3 for t is greater than or equal to 0. It says find the velocity and acceleration, okay? All right, so I'm actually about to run out of time on this video, so I'm going to start a second video where I go over the 2 example problems with a couple parts, and then show you guys the homework and stuff too, okay?